All right, let's dive into one of the biggest, most exciting shifts happening in AI right now, AI agents. We're talking about moving past AI that just, thinks, and into a world where AI can actually do things. This is the whole journey from a brain in a jar to a capable, active teammate, and we're going to break down exactly what that looks like.
And this quote right here, it just nails it. We've had these incredibly powerful language models for a bit now, but an agent is what makes all that power useful. It's kind of like the difference between a high-performance engine sitting on a workshop floor and a car that can actually drive you somewhere. We are leaving the world of AI that just predicts things and entering a world where AI does things.
So here's our game plan. First, we'll talk about that brain in a jar problem, the big limitation of AI models today. Then we'll see how agents fix that by giving them hands. After that, we'll get into the messy integration chaos that happens at scale and how a universal language, MCP, is coming to the rescue. Then, of course, we've got to talk about the risks, and we'll wrap up with how we can build agents we can actually trust.
Okay, first things first, let's really unpack this brain in a jar idea, because it gets to the heart of the problem. You see, a standard large language model is this amazing reasoning engine, but it's totally cut off from the real live world. It's a brilliant brain for sure, but it's stuck inside its own box.
Think about it this way. You can ask a model to write a detailed history of the Boston Red Sox, and it'll give you a masterpiece. But ask it for the final score of last night's game? Nothing. Crickets. Its knowledge is basically a snapshot in time, frozen when it was trained. It can't see your latest sales data, it can't check the weather, it is completely blind to the present moment.
So how do we fix this? How do we get that brain out of the jar? Well, the answer is AI agents. We basically give that brain a body, or at the very least, we give it some hands. And these hands are what we call tools. They're the connection between the model's brain and the outside world.
So this is the basic anatomy of an agent. You've got the model, that's the brain, doing all the thinking. You have the tools, those are the hands that can take action. And then, and this is super important, you have the orchestration layer. Think of it as the nervous system. It takes your request, figures out the steps, and decides when to think and when to act.
These tools fall into a few different buckets. Some are all about knowing things, like searching Google or pulling data from a database. Others are for doing things, like actually sending an email or updating your CRM. And some are for teamwork, like pausing to ask a real person, hey, is it okay if I do this before a big step?
But here's the catch. For an agent to use these tools, it needs to understand them. And this slide shows why that's so critical. On the left, you've got a tool with a super clear name and description. The AI knows exactly what it does. On the right, it's vague, cryptic, and AI would have no idea what to do with that. This clear documentation is absolutely non-negotiable for getting agents to work reliably.
Okay, so agents are awesome. We connect our models to some tools, and they can do all sorts of cool stuff. Problem solved, right? Well, not so fast. What happens when you have dozens of different models and you want them to connect to hundreds, maybe even thousands of different tools? You run into a brand new massive problem, integration chaos.
This is what's known as the N by M integration problem. For every N model you want to use, you have to build a custom integration for every M tool. And that gets out of hand really, really fast. It's just a tangled mess of custom code that's impossible to maintain. And this right here, this is what that chaos looks like. Every single one of those arrows is a custom piece of code a developer has to write, test, and then fix when it breaks. Want to swap in a new model? Good luck. Want to update your API? Get ready for a world of pain. It's slow, it's expensive, and it just does not scale.
So how in the world do you solve a tangled mess like this? Well, with a solution that's worked time and time again in technology. You create a universal standard. You make a common language that everybody agrees to speak. And that standard is the Model Context Protocol, or MCP. Honestly, the best way to think about it is like USB for AI agents. Instead of a different plug for your keyboard, your mouse, and your camera, you just have one. MCP is that one universal plug. Any model that speaks MCP can connect to any tool that speaks MCP. It creates a true plug-and-play world. So how does it pull this off? The architecture is actually beautiful in its simplicity. It just breaks the whole system down into three parts. You have the host, which is your AI app. You have the client, which talks for the agent. And you have the server, which offers up the tools. This clean, modular design is what makes it so powerful and so scalable.
But the real secret sauce of MCP is how it defines a tool. It's a standard contract with these four key parts. You've got the name, which is just a unique ID. You've got schemas for input and output, which is the technical part, but the description, that's the magic. It explains what the tool does in plain English so the AI can figure out when it should use it. This little tool card is what lets any agent find and use any tool all on its own with zero custom code.
Now, creating this plug-and-play ecosystem is, well, it's a game changer. It makes everything faster and opens up a whole universe of reusable tools. But giving an AI a universal key to connect its brain to the world's hands, that also unlocks some new and pretty serious security risks.
Which leads us to the really big question, right? Just because everyone can now speak the same language, does that actually make things safe? Or does that universal plug just make it easier for the bad guys to connect their malicious tools too?
One of these new threats is something called tool shadowing. You can basically think of it as a phishing attack for AI. A malicious tool pretends to be a trusted one. It might call itself get_customer details to trick your agent into handing over sensitive info, which it then promptly steals.
And then there's a classic security problem that gets a new life here, the confused deputy. Picture this. You have an agent with high-level access to your company's code. An attacker with zero privileges tricks that powerful agent into doing its dirty work, like making a top-secret project public. The agent itself isn't evil, but it's been tricked, confused, into misusing its power.
And even beyond these direct attacks, there are some really practical headaches for developers trying to use MCP in a big company. For one thing, loading hundreds of tool descriptions can eat up a model's precious context window. There's also no standard way to pass along who the user is, which makes permissions a nightmare. And there's no built-in way to log or trace what the agent is doing, which is a must-have for security and debugging.
So what this all means is that we can't just build these powerful agents and then let them run wild. We need a new discipline, a structured, professional way to build, manage, and secure these things, especially inside a business.
And that new discipline is called AgentOps. It's the logical next step from things like DevOps and MLOps, but it's built specifically for the weird, unpredictable nature of AI agents. AgentOps is all about taking that unpredictable behavior and turning it into a reliable, safe, and measurable system.
And this brings up a huge shift in how we even measure success. You know, with traditional software, it's pretty simple. It either works or it doesn't, pass or fail. With agents, it's way more nuanced. We have to evaluate the quality of their work. We ask things like, did it use the right tools in the right order? Was the final answer actually correct? And maybe most importantly, did it just make stuff up or did it say something harmful?
And really, this all leads us to the final, most important question. Agents are becoming more than just tools. They're becoming our collaborators, our teammates. So the real challenge isn't just about making them powerful. It's about engineering them from the very beginning to be trustworthy. Because honestly, the future of how we work is going to depend on it.